Hello and welcome back to Excel. Today we're going to talk about if-then statements. This section is probably the most complex section of Excel that we will have for the semester. So please hang with me, work through this. It is a very important section for a number of reasons. But please try and work very hard on this section and understand how if-then statements work. So today our objectives really are to look at our relational and logical operators. We'll start with that first. Then we'll go into just simple basic if statements, and then the more complex nested if statements. So let's start out with our relational operators. Relational operators work at looking at some condition and telling us if something is true or false. Relational operators only give us a 1 or a 0 or a true or a false, essentially. They answer questions. They can answer questions like, are you older than 21? If the answer is yes or no, means that it's true or false. So you're just doing a comparison. So this relational operators are really just comparison operators. We know them as your basic equals, right? So if you're equal to 21 or less than, or not equal to 21 or less than or greater than 21 or less than or equal to 21 or greater than or equal to 21. These are all the symbols that will be used for Excel for our relational operators. So these compare two variables or relationships between two variables and returns a result of true or false. These relational operators work not only on numbers, but they also work on strings. And strings, remember, is text, right? It's text. And this is very important to remember. For an example, here's a string. If it's less than, it means it precedes it. So is A less than B in the alphabet? Yes, it is. So this would be true. Here it's greater than. Is Q greater than D? Of course it is. That means it's true. Please be aware that this exists. This could be words. Also could be apple and banana. It'll look at the first letter and like alphabetize it to know if it's one's before the other. I will guarantee you that something like this is usually on an exam. Students come back to me and say, we never learned anything like this. We don't use it very often, but this is very important to know and will be on the exam. I will guarantee that for you. Okay, let's go on. Let's look at an example. Let's say we're given a cell B3 equals 5 and a cell C4 equals 6, and we're supposed to determine this expression. So we have this expression where we're taking B3 and adding it to C4. We know that that is at a value of 11. We want to know if that is less than 2 times B3, which is 10. Well, we know that that is not true, right? 11 is not less than 10, so our result for this expression should be false. It's not true, okay? How is this written in Excel? This is written, again, because it's an equation. We write it with an equal sign. That is important. And then we have our parentheses adding up, B3 plus C4, and seeing if that is less than B3 times 2. Okay, so that's how we set up our relational operators. And we could do this as greater than, less than, or equal to, any of those different relational operators. Okay, so these relational operators require an operand on both sides of the operator, right? So this greater than or less than, there's got to be something on either side. I could also have, like, I could have had B3, is that less than 6, right? It doesn't have to be a variable. It could be just a regular number itself. The result is always Boolean, meaning it's true or false, and they are evaluated from left to right with no order of operation. Now let's look at logical operators. And we'll do examples in a separate video on all of this. Let's look at logical operators. Logical operators are used to join two Boolean expressions, so like and. So it is sunny today and greater than 70 degrees. If that is true, that means both of those things have to be true. If one of those, it could be sunny and negative 32, then it's not a nice day, right? It could be false then, that say. We want it to be greater than 70 degrees. We could do or. Maybe we want to go outside if it is sunny or it is greater than 70 degrees. It could be raining and 70, we would go out, or it could be 30 degrees and sunny, maybe we'll go out. And or means that only one of the conditions have to be true, okay? And we can have more than one and or more than one or statement, right? We could have it be sunny or greater than 70 or my wife tells me to get out of the house or something like that. That means we need to go outside, right? Something like that. So if one of those are true, I better go, right? As opposed to and. And would be it's sunny and it's greater than 70 and my wife tells me to get out of the house. Then I better have all those expressions to be true for me to go outside. Not is just taking the reverse of it, right? Not will just say if it's true, now I'm going to make it false. Or if it's false, I'm going to make it true. That's all it does. It just reverses our outcome. So how is these logical operators, how are they represented in Excel? We use them with the function and. So here's the and one. It would be equals and. Right, not negative really. And in this case, C3, looks like K3, sorry, B3, right? So there should be an equals in front. Both those things have to be true. So whatever's in C3 and B3, if they are, they need to be true in order for this to be true, okay? Or something could be or, right, to be true. And we just have an or with an equals in front, really. And not just makes that negative. It just reverses it. It's like multiplying it times a negative 1. Okay? So we can use these logical operators as an example, right? We can test to see if cell B6 is between 8 and 20, right? This would be a logical operator. So it has to be an and. This is an and. It needs to be between both of those. So we would look at it something like this, right? This is the way we would think of it, right? Is B6 greater than 8? And is B6 less than 20, right? If it is, then it would be true. The way we write it in Excel, though, is this way, equals. And we say, 8 is less than B6, and B6 is less than 20. So this is the way it is written in Excel, not this way that it's written in the first line. The second one is the way we would do it. Neither of these are valid. Even this last one on the bottom is not a valid expression in Excel. It will come back with an error every time. You must use this and in the middle, like this. Or in the beginning part, excuse me. In the middle of the 3 examples here. Okay, so order of operation. To evaluate Boolean expressions. Again, arithmetic operations are first. Relational operators have all the same precedence. And logical operators go in not, and, or. That's the relationship for logical operators. Okay. We're going to use those logical and relational operators to determine things in an if-then-else statement. So how does that work? Let's take a look at what they are. And why do we even want to do these things, right? What are they used for? If-then-else statements are used for making decisions, right? It could be used for a lot of different decision-making type things. Could be maybe there's a sensor you're monitoring on the line, on a manufacturing line, and if that sensor says that the temperature is greater than 110 degrees, I need to start cooling it. So I need to turn some valve on to start cooling it. Might be an example. There's a number of these if statements that we use in life, and they're very important to really understand. It's the basis really for decision making, right? It's for our decision making. Do I want to cool the substance? Do I not want to cool it? Do I need to add something else to it? All these are really, these if statements are really decision-making processes. And that's the way the computers actually work for making decisions. If statements are very powerful that way. Okay. A lot of times we have more complex ones, right? We may have we're going down a path in a maze, and do I go straight or do I go right? I may go right and then I come around again. Do I go straight? Do I go left? I mean, is these all decisions trying to get us to the final goal? That's a more complex situation, and we'll look at that in just a minute. So these if statements really are for making decisions, right? We want to make decisions. And we do this, we're going to demonstrate this using some flow diagram type work. And this is what's used a lot in computer programming, and I highly recommend that you learn how to use this. You will need to do this on your homework also. This triangle or diamond shape is used for our decision-making process. That is our if statement, right? That's where our if statement goes. And in this example, we're going to check to see if it's raining outside. Okay, if it is raining, that's what we want to know. And we have two options, right? It is either raining or it isn't raining, right? So we have a possibility of raining or not raining, right? If it is raining, that means it's true. Is it raining outside? It is raining. That's true. What do we want to do if it's raining? You know, and then the other option is if it's not raining. So those are our two options, right? So what do? We have these blocks here, which tells us our command of what we're going to do, our result, right? So if it's raining, we're going to take an umbrella, all right? If it's not raining, go outside. It's a very simple operation, right? It's making a decision. Should I take an umbrella or shouldn't I? Let's look out and see if it's raining. Our brain does this very quickly, but programs need to have this all programmed in. The logic needs to be there, and this is the logic that's used, these if statements. All right, so if it is raining, then take the umbrella. If it is not raining is the else. So it's if, then, else. If, then, else statements. You'll hear that. So if it is raining, then take an umbrella. If it is not raining, else, go outside. Okay. So again, this is how it's kind of set up. If some condition is true, so if it is raining in our case, then we'll do action 1. Else, we'll do action 2, end if. That is the kind of the logic that's used in computer programs, right? And then we do different actions based on our condition, the result of our condition. And these conditions, again, are typically our Boolean or relational operations. That can be and ors. It could be just simple greater than or less than or equal to type statements, things like that. In Excel, this is how we set up our if statement. So if we say if, we have some logical test. That logical test is our relational operator or logical operators combined with our relational operators. And if that test is true, we will do something. We'll set some value to, if it's true, we'll do something, and some value if it is false. So the logical test to see if some condition is true using relational logical operators. And then the green is always if it's true. So after that comma, the next part is the green part, which is the true part. And it could be a value of something. It could be a text string, right? It could say, take your umbrella, or it could be a number of 20 or something like that. If it's false, this can be a value again, or a text string, or it could be another if statement. So this is where we get our nested if statements, and we're going to talk about that in just a little bit. Okay, that's for more complex decision making. So here we are. Now, how are we going to write this into some Excel statement? Again, we know it needs to follow this format of if equals if, open parentheses, some logical test, value if true, value if false, close parenthesis. So what is our logical test? This logical test is we're going to check some cell to see if it is raining. So in this case, we're going to see if A3 equals rain. If it says rain, then we want to take our umbrella, right? So this is our logical test. It's an equals, right? Could be greater than, less than, if it's a number or value or something, or a string and I want to know if something's alphabetized or something like that. But in this case, I'm looking to see if it's raining, right? If it's raining, okay. And notice it's in quotes, so any text always has to be in quotes. And if it is raining, right, then I want to take an umbrella. So I'm just going to write in quotes, take umbrella, right? There's my take umbrella. So that's my true statement. If it is false, so if it's not raining, it could be sunny or something else, then go outside. Okay? So there's my if statement. So this is a simple, basic if-then-else statement. We can write this statement just as we would in any cell and write it that way. We can also click on that f of x function and type in if, and we can create our own logical equation just by typing it in. You can go to help on this function and it will give you all the help that you need. This is always a great way of looking at it. But again, we have our logical test. Here we're doing something G10 is less than H10, and it's already saying, oh, that's true, right? We're looking at this G10 and H10. So G10 is less than 6, so that's true, and we say, you bet, otherwise it would be no way. And it's going to automatically create our parentheses and everything else that we'll have in there. All right, let's look at nested ifs. So that was just a basic if statement. Nested ifs are more complex, like this maze, right? I made the one decision here of going right instead of going straight. And if I did that, then I have to make another decision. Do I go left or straight? And then after that, I have another decision, and I can go straight again, or I can go right again. Then I make another decision. Do I go left or right? On and on this will go, right? And I guess there's a decision here and here even, really. All along here, this maze, I have these decisions. And that is a much more complex problem. Excel is very accommodating for something like that, and we'll look at that in a second. So let's look at this situation here. This is where we were before, right? If it's raining, I take my umbrella. If it's not, I'm going to check something else. What should I check? Let's check to see if it's snowing. That might be another option. So if it's raining, I'm going to take my umbrella. If it's snowing, I have two options again. It's either not snowing or it is snowing. If it's snowing, that will be true. And if it's not snowing, it'll be false. And again, I have some options of what they will be. And if it's snowing, I'm going to say wear a coat. And if it's not snowing and it's not raining, so this tells me it's not raining and it's not snowing, then I'm going to just go outside. Okay, so this is a more complex one, kind of telling me how I should dress in the morning, right? My sensor's going out there checking to see if it's raining or seeing if it's snowing. And if it's snowing, I'm going to wear a coat. Otherwise, I'm going to take an umbrella if it's raining. Otherwise, I'm going to just go outside. How do we write this in Excel, right? We can set up our equals if rain umbrella. We already did that, right? That's this top portion here, right? That's that top portion. And you see I have this parentheses way out here, and that matches up with this one here. That's very important. And I have my comma, so this was my true statement, right? And now this is my false statement. What did I want to do there? I want to check now. If it's false, I want to check if it is snowing, right? So I'm going to say if snow, right? Then I have some true statement or false. Notice when I put this if statement is, I have a second set of parentheses, these purple ones. And Excel will color code them also, but it's very important to keep track of these parentheses because it gets rather confusing. All right, so if it's snowing, I have my two options again. True, I should wear a coat. We'll just write coat. If not, it's false. Go outside. Right? So there's my if statement for Excel in working this. Okay. Notice this section part here, this that I have starred and with the brackets, that is my nested if. That is that second if statement. If it's false, it's going to do this other option, these other arguments. Okay. I could also nest it in the true part if I want. Typically, I always set up as the false part. You may have other branches coming down from the true, right? It might wear an umbrella, but maybe it's something else. I'm going to just take a raincoat or something, depending on how hard, like raining hard. Raining hard, wear a raincoat. Not raining hard, take an umbrella. I could break it out that way and have a different if statement there. So I can have multiple if statements, but typically I just work it off of the false side of things. Excel gives us the ability to do 64 nested if statements. That's a lot of if statements. I've never written one that long, and it would be very complicated to do to check that all. But it allows us the ability to go that deep on if statements. We can write if statements to check maybe a sensor to see if it's ice, water, or steam. You can see if it's ice, water, or steam, and we're going to check the temperature in cell B4, right? And how do we write that? We're going to write it with this equation here. Let's see if we can understand this. It says if B4 is equal to or is less than 0, so I'm going to have if B4 is less than 0. If that is true, we'll make that T. That says it is ice, right? It's less than 0 degrees. It is ice. Okay, this is in centigrade. If it's false, then I've got to check something else. And now I'm checking to see if B4 is less than 100, right? If it is less than 100, I have H2O, water. Otherwise, I have steam. Water, ice. So here is my nested if statement in here. Okay, and you can test and put these values in and tell us what we have, right? If B4, it's going to test each of those cases. Okay. All right, let's go through some examples. This is kind of fun to see if it's moving on you or not. But let's go through some examples, and I'll do that in another video for you. All right? Enjoy.